Assalamu alaikum students, how are you all? Good? I hope and pray everyone is all well and fine and doing well. Welcome to our lecture number 8, which is about the second part of the internet security. And here we'll be talking about a particular protocol, a very famous credible protocol that is almost used in every kind. I would say 99% of the time it is used in securing web related communication or internet related communication. Okay, the last time we discussed an application, a very important application at the application layer or in the internet, which is the email, and how can we secure it. We talked about two protocols of how PGP, we talked about PGP and SMIME, and we understood that how do they operate to provide security to our emails. Okay, now at the internet we also have other applications, a number of applications, just like smart what do you call it, file transfers. We have the general web communication, which is the HTTP communication. We have we can remotely log in into various applications, various computer systems, various operating systems. So there are a large number of applications that still needs protection. Right now, SSL or secure socket layer is essentially a transport layer protocol. Okay, it works at the transport layer, but it's a generic, you can say it is a plugin that you can attach to any kind of web communication or internet communication, whether it is file transfer, whether it is emails, whether it is some other kind of communication, web communication, HTTP communication. So you can attach it to, or make use of it to secure any kind of application level communication. Okay, so let's have a look at it. How does it work? What are the concerns related it? What are the different stages? So we'll be having a look at the major thing that we'll be discussing here is how does this protocol works. Okay, so this is what a transport layer security mechanism, which means that we have layers in the network. Right, in the network communication we have two stacks of models, which is the OSI model, or the other one is the TCP/IP model, or which is also called the internet model. They all have layers, starting from the application layer, and then at the end we have the layer 5 in the TCP/IP model, or the layer 7 in the OSI model, which is the physical layer. Okay, each and every layer performs certain kind of functionality that is applied to a packet that we want to communicate. Right, security is one aspect of the functionality that we might want to associate with our communication, apply its mechanisms on the packet, so that it is communicated in a protected manner, in a secret manner. Okay, so the two protocols that we talked about the last time, the PGP and SMIME, they works at the application layer. Okay, this one here, the secure socket layer, which has two versions, we'll have a look at it later. This works in the transport layer. Okay, so this is essentially fundamentally a transport layer protocol. Okay, now why did they give it this name, secure socket and layer? Now it's kind of a secure socket layer is a protocol, but they consider it as an intermediary layer between the application layer, fine, and the transport layer. So you can see when you are trying to send out message, the message has to go to all these layers. Right, they say that this is a secure socket layer. Sockets, sockets is just like we have electricity sockets, we have pipe sockets for piping, etc. So this is a layer. They say that this is a logic, and this is not a layer at all, but this is the layer name, the name keyword here indicates that this is applied to application data that is coming here to the transport layer. Okay, so logically you can say that this is a plugin, or this is a security mechanism that is being applied to any kind of application data that is going from the application layer to the transport layer. Okay, so it provides a socket mechanism. Fine, a socket mechanism, which means that it provides, that socket performs what, security related operations or functionality on the application level data. So it is a standard for internet security. Fine. We will be discussing two things here. Majorly, this protocol comes in two forms, shapes. One is called SSL, the other is called TLS, Secure Socket Layer and Transport Layer Security. They are essentially both the same. The first, in the beginning they come up with the secure socket layer, and then they evolve it after version 3 of the secure socket layer. They come up with another protocol that can also be used for the same purposes, for the same services as that are offered in the SSL. Okay, and they called it what? Transport layer security. So you can say that they are cousins or siblings. The only difference, the objectives remain the same. The only difference is their working. There's a bit of a difference between their design. The algorithms, the working is different. The design objectives are the same. Okay, and both are used to secure internet related communication. Now internet is composed of a large number of communication, whether it is file transfer, chats, whether it is a remote access to any kind of remote machine. Fine. For all these kind of applications, you can adopt or you can use the SSL or TLS. Okay, in practice, most commonly it is used to protect the information that is transmitted between browsers and servers. Just like you have seen HTTPS and then www.sku.edu.om. Okay, that S indicates that this is a secure HTTP, which means that we have adopted or we have applied the SSL mechanism, the SSL protocol to protect our HTTP, because HTTP by default inherently it doesn't have any security mechanism for the HTTP request and HTTP response. Fine. If someone intercepted, they can easily see what's happening on. Right. So we have to secure it. There are situations, for example, for online banking, for logging into these portals. Fine. This involve sensitive information communication. So we have to protect that. So SSL is one of the mechanism that is most commonly used for web related communication, which is our HTTP. But it is not limited to HTTP. You can use it with any kind of protocols, with any kind of application, even with emails. If you look at the Gmail, fine, the Gmail is doing what? When we log in through our browser, we are connected to the Gmail server where we write our emails and then send it. The email is sent from our browser to their servers, right? Now this transfer from our browser to the server, Gmail server, is conducted is protected using the HTTPS, which means that it is protected using the SSL. Fine. And then later on they may also use some other protocols for its protection, maybe SMIME and things like that. So you can use it for any kind of application data protection. So as I mentioned earlier, TLS is based on secure socket layer protocol. It is entirely based on the SSL. TLS is another protocol. The objectives of the SSL and TLS are the same, which is authentication, data integrity, encryption, confidentiality, everything, compression. We'll have a look at them. Fine. The only difference is the working of the algorithms. And you will see, we'll have a look at some demos that there are a large, and they are compatible with each other actually. Fine. Not compatible in a sense, but they are agreed, and almost every browser has the ability to perform either one of them. So today's browsers, they are properly capable of dealing with such kind of communication, such mechanism that is being employed by the SSL or the TLS. We will be sticking to these SSL. Okay, we will be discussing the SSL. Okay. So where is it implemented? As I mentioned earlier, it is essentially implemented at the transport layer. At the transport layer where our TCP protocol is, transmission control protocol is. I hope you remember this protocol. Okay, which is responsible for session management, fragmentation, and everything. But we can visualize this as we can visualize SSL or the TLS protocol as a sublayer or as an intermediary layer between the application layer and the transport layer. This is your transport layer. Fine. And this is your network layer. So that when the data moves in this fashion on the sending side, the data from any application out there, whether it is email, web, whatever it is, it has to go to the transport layer. So what it does is that first of all the data is operated by or being processed by, if it is required, fine, it is processed by, if you want to protect it, it is processed by this layer, by this protocol, fine. So it seems like logically we can say that SSL is a layer, but it's not a layer, it's just only a protocol, fine. And when it is protected, when that packet or when the data item is protected, then it is transferred for the communication to the transport layer. Okay, so the transport layer then perform its own communication and then functionality, and then forwards it further. So it is essentially fundamentally a transport layer protocol, but logically we can see or we can visualize it as an intermediary layer between the application and the transport layer. This is just a visualization, conceptual visualization. Okay, this is not the reality. The reality is it is implemented at the transport layer. Now what services does it offer? Fine, what kind of SSL security services are being offered by the SSL? Number one, it performs fragmentation, which is actually a function of the transport layer as well. Fine, because it's a transport layer protocol, so it has to perform that as well. Fragmentation means that when data that we want to send is big for communication, we have to fragment it down, divide it into chunks, so that it is easier for us to process and send it across. So first, SSL divides the data into blocks. Each block is 2 raised to the power of 14 bytes, or maximum 2 raised to the power 14 bytes. Okay, then each fragment is compressed, and this is optional. Compression is optional. Each fragment is compressed. Why? Because sometimes they might further want to compress the data, why? Because if you remember, if you recall, when we are performing confidential encryption or creating digest of messages, of the actual message, of the actual data, it takes more time, so it will be better to first compress it. Fine, so compression is applied here, but it is optional, not required. Then it also gives us the message integrity, data integrity. Fine, and this integrity here is both the origin integrity and the data integrity, origin and the data integrity. It offers both, which means that it is employing what? The MAC mechanism, which is message authentication code, which is a keyed hash. Okay, it's not for message integrity, it makes use of a keyed hash, which means that there is some symmetric keys involved here. So to preserve the data, the integrity of the data, SSL uses a keyed hash function to create the MAC using a symmetric key. So which means that SSL for message integrity, it is using what? A keyed hash or an HMAC or a MAC. Then it also provides confidentiality, which is one of the biggest important objective here, to provide confidentiality, which means that it will be performing what? Encryption, right? The original data and the MAC are encrypted using symmetric key. Again, if you recall, for the majority of the communication, if we want to protect it, if we want to make it confidential, we have to apply the symmetric key cryptography. Why? Because it's much more efficient as compared to the private key or public key encryption. So for encryption purposes, for confidentiality purposes, it uses which algorithm does it use? It depends. Which algorithm does it use? It depends. We'll have a look at that one. Fine, but it uses a symmetric key algorithm for the encryption. And then framing means that when everything is all protected, when the entire data is all protected, when the message integrity is ensured, when the data is compressed, fine, when the confidentiality is achieved, then the message is prepared for transmission. This is called framing. Fine, like when you want to put up a picture in your house, you prepare it properly, you frame it properly, and then you put it on the wall. Fine, at the end. So framing is related to the preparation of the packet for communication. Fine, So when the packet is ready, which means that when the packet is properly protected by the SSL, at the end it has to transmit it, not keep it in its pocket, right? It has to transmit it. So for transmission, it make use of the framing concept. Fine. So which is a mechanism that help us to properly wrap up the packet and send it across. So a new header is created to the encrypted payload. Whatever you have done protected here, payload means the data, and then the payload is passed to the reliable transmission layer protocol. Depending upon transmission, reliable transmission is what transmission in the networking? TCP, remember, because it creates a session for you, and session provides you reliability. Fine. So it make use of the TCP protocol later to transmit the SSL packet. Okay, the SSL packet. Now there are two major steps involved in the SSL operation. We will go from top down, from top to down, so that we can understand it properly, and each of these steps will be further explored. In the first step, a session is established, and it's not just a regular session. It is a much more sophisticated session establishment creation between a client and a server. Okay, for their communication, protecting their communication. During this session, what happens in this session? Okay, they agree, the client and the server agree on algorithms. Which algorithms? The algorithms that is necessary for compression, the algorithm that is necessary for confidentiality, and the for message integrity. So both the parties, communication parties, first agree on these algorithms. Fine. When they agree on these algorithms, these algorithm requires what? Keys, right? Because encryption required keys, and the hash make also required key, because this is a keyed hash. So we need to then establish the keys, the symmetric keys required for them, for achieving these objectives. Okay, so when they agree on the algorithms, they create and share these secrets. Secrets means the symmetric key. Fine. And also they perform authentication of each other. Authentication of each other means the client authenticate the server. Server authentication is a must in SSL. Okay, server authentication is a must in SSL, but the authentication can also be mutual in situation. What does mutual authentication means? Mutual authentication means that both parties, communicating parties, authenticate each other. Okay, so it also helps us to provide authentication, and this authentication is usually conducted using the digital certificates. Certificates. Okay, this is done to digital certificates. And then when everything is all prepared, see, everything is all finished, the session is established, what we need for security, the algorithms, the keys, the authentication, they are all performed in the session establishment. This process is also called the handshake. Session establishment is also called SSL handshake. Okay, when the handshake is performed, which means that everything is now set up for secure communication, then the transfer of the data happens, whether it is HTTP data, whether it is email data, whether it is file transfer data, what type of data it is. Then we start that secure transfer of the application data, and that ensures what? Both confidentiality and integrity. Fine. So authentication here is used. This one is used for the entities. In the session establishment, in the handshake, the authentication is used to authenticate the entities, which are the client and the server. Later on, for the message authentication, we make use of the integrity protocol, which is the MAC. Okay, mechanism, which is the MAC. And this is only done once. For each session, authentication is performed only once. Fine. Whereas for each message packet, both confidentiality and integrity are achieved. This is the general architecture of the SSL. Okay, so on the top here you can see that this is our application layer. HTTP means what? It is an application layer protocol. Okay, application, and this is our transport layer. And we mentioned that logically we can place SSL somewhere in between it. So SSL majorly, SSL have 4 components, or you can say 4 algorithms or 4 sub-protocols. Fine. These sub-protocols are the change cipher protocol, They are all part of the SSL. Okay, the alert protocol, the handshake protocol, and the record protocol. Okay, the handshake, let's just start with this one. The handshake is responsible for the session establishment, which means what? The agreement on the algorithms, the creation and the sharing of the secret key, and the authentication. Okay, so this is done in the beginning. This is the first protocol that initiate the SSL communication. Okay, during the communication, whether it is the handshake communication or later on in the data transfer, if there are some certain errors occurs, if there are some errors that occurs, those error handling is being conducted by, performed by what? By the alert protocol of the SSL. So the alert protocol is responsible for handling all the errors that are related to SSL related communication. Okay, what is change cipher spec? Change cipher spec is a protocol that either confirms a secure connection, okay, or what do you call it, or initialize. So whenever there is a change in the security measures, whether it is in the beginning of the handshake or whether it is a new handshake to be performed, fine, or resumed, a session is resumed, this protocol helps to confirm that the new security measures are now in place. So this is more of a flag message, fine. It provides a flag message, a confirmation message that our secure communication has been initialized, or our secure communication has been, agreements has been concluded, fine. So this is only responsible for flagging out both the parties, which are the client and the server, to let them know of the new security changes in there. The record protocol, the record layer protocol, this is not a layer, this is a protocol, the record layer protocol. This is responsible for the framing. Remember the framing, preparation of the data, fine. So whatever packet is it, whether it is responding to, whether it is a handshake what do you call it, message, or whether it is an alert message, or whether it is SSL process, whatever is SSL process data, fine. That SSL process data is being transferred by, or being framed by which protocol? By your record protocol, fine. This is done by your, so it handles the data compression as well as the data transfer. Which data transfer? The SSL data transfer. Okay, to which layer? To the TCP layer. So it prepares data, it prepares the packet, the SSL packet, for the transport layer protocol, which is the TCP. Okay, we cannot use the UDP protocol, which is also here at the transport layer. Okay, for SSL we always make use of the TCP, which is a more reliable protocol than the UDP. Okay, what is a handshake? Let's have a look at them in detail. What is a handshake protocol of the SSL? This helps us to initiate, to start the session of the SSL session. Okay, so during this session, during this handshake communication, during this agreement, a number of cipher suite algorithms are presented, fine, by the parties, mainly by the client, fine, and they agree. They negotiate which algorithm will be used for encryption, for confidentiality, which algorithm will be used for compression, which algorithm will be used for message integrity, fine. So here we negotiate the cipher suite. Suite means the combination of the ciphers for confidentiality, for integrity, and for the compression. Okay, so and also for the key exchange. So this negotiation includes what? The symmetric cipher to use. Which symmetric cipher will we be using? Cipher means the encryption algorithm. It specify the key exchange method. The key exchange method means which, for the encryption, for the hashing, for the HMAC, we need the keys, right? So how will they be created and how will they be transmitted? It is also being confirmed here. And also which hash algorithm will we be using for the message integrity? It is also negotiated here in the handshake. Okay, it establishes a shared master secret. Okay, share master secret, it is actually a pre-master secret. To be technical in nature, it's called a pre-master secret. See, for the encryption, for the message digest here, we need the keys, right? Now the keys, this is the we need the keys, right? Now these keys that are required for these security services are actually being extracted or derived from a secret that we call the pre-master secret. Fine. This is created by the client always, and then later on transmitted to shared with the server using the SSL protocol. And using this pre-master secret, when they both have a copy of this one, this is a common secret. Fine. Both the client and the server make use of this key to create further keys. Further keys for what? For encryption, for authentication, for message digest, okay, for the HMAC. So PMS is created and shared where? In the handshake protocol, okay. And later on they make use of this PMS. This is actually a seed, you can say, a seeding value that is used to create more keys. Why do we need more keys? Because we need different keys for authentication, message authentication or message integrity, and we need different keys for encryption. Fine. So this is called the pre-master secret, and this is created by the client, shared with the server in the handshake protocol, and then both of them make use of it to create other keys. Okay. And handshake, as we mentioned earlier, is also responsible either for one-way authentication, which means that the server will be authenticated. The server will always be authenticated in SSL communications, okay. Whereas you can also perform mutual authentication, which means that both parties, communication parties, which are the client and the server, they may also authenticate each other. And this authentication is based on what? As I mentioned earlier, on the digital certificates, okay. And this is the authentication of the entities, the client and the server. Okay, I will come back to the handshake protocol in another part. Stay with me.